Hello everyone, welcome back to my channel Explain Maths. Now in this video I will be covering the remaining questions of exercise 9.5, that is question number 4 to question number 8. And again I will repeat that these questions I have taken from the old NCERT textbook because according to me these questions are really very important. So I felt I should cover those questions as well. So let's begin the class. So question number 4, simplify. The first question is a square minus b square whole square. Now if you can see here, this question which is given is, it is in the form of the standard identity a minus b whole square, right? And what is a minus b whole square? Last class only we have done this, right? A minus b whole square is a square minus 2ab plus b square. So now I'm going to use this identity to simplify the question. So here a square means it will become a square whole square minus 2 into a square into b square plus b square whole square. Now why it is a square whole square and b square whole square? So if you compare the question from the standard identity, your a is a square and your b is b square. That's why when I have to write a square, it is a square whole square. Same way b square is b square whole square. Now a square whole square will give me a to the power 4 minus 2 times a square b square plus b raised to the power 4. So this is the answer. Now the second question. 2x plus 5 whole square minus 2x minus 5 whole square. So if you just carefully, if you observe, if I consider this as my a and this as my b. So this is a identity which is a square minus b square. And we know that a square minus b square is a plus b and a minus b, right? So now here your a is 2x plus 5, b is 2x minus 5. So first I am doing a plus b. So it will be 2x plus 5 plus 2x minus 5. So that I can keep it in bracket also, right? And then a minus b. So 2x plus 5 minus 2x minus 5. Now let's simplify it. So this will give me 2x plus 5 and before bracket there is a plus sign. So there will not be change in sign of the expression which is given within the bracket. So it will be as it is 2x minus 5. Now here it will be 2x plus 5. Now before bracket there is a minus sign. So the sign will change for the expression which is inside the bracket. So it will become minus 2x plus 5, right? And now 5 and minus 5 will become 0 and here 2x and minus 2x will be 0. So I am left with 2x plus 2x which will give me 4x multiplied by 5 plus 5 which will give me 10. So 4x into 10 will give me 40x. So this is question number 2. Now moving to question number 3. So if you see the third question, it is given 7m minus 8n whole square plus 7m plus 8n whole square. So if you see the first one is a minus b whole square and here second one I can use as a plus b whole square. Now here I cannot use the identity a square minus b square like I have done in the previous question because here there is a plus sign. So I cannot use this identity. So what I will do, I will use a minus b whole square and here a plus b whole square. So a minus b whole square will give me a square minus 2ab plus b square, right? And a plus b whole square will give me a square plus 2ab plus b square. Now let's use a minus b square in the first expression. So it will become 7m whole square minus 2 into 7m into 8n plus 8n whole square plus, now for the second expression a plus b whole square, it will be 7m whole square plus 2 into 7m into 8n plus 8n whole square. Okay. Now if I can see something, I can reduce it. So if you see minus 2 into 7m into 8n, and here is plus 2 into 7m into 8n. So I can cancel it out. Now 7m whole square will give me 49m square plus 8n whole square will give me 64n square plus again 7m whole square will give me 49m square and 8n whole square will give me 64n square. Now combine the like terms. So you can see 49m square here and 49m square here. So 49 plus 49 will give me 98m square. Then 64n square is here and 64n square is here. So 64 plus 64 will give me 128n square. So this is the third question. So you have to first think which identity you are going to use, and then slowly you have to uh, see how to write the given expression in the identity form, and then you have to solve it. Now moving to the fourth question. The fourth question is 4m plus 5n whole square plus 5m plus 4n whole square. So here also I can use a plus b whole square in both the cases. So if you already know how to do this, so I will suggest please pause the video and then solve it by yourself. So a plus b whole square is a square plus 2ab plus b square. Now a square means here I will write 4m whole square, isn't it? This is my a, this is my b, plus 2 into a into b means 4m into 5n plus 5n whole square. Now same way for the second expression also I am going to use a plus b whole square, but here my a will be 5m and b will be 4n. So a square will be 5m whole square plus 2 into 5m into 4n plus 4n whole square. Now 4m whole square will give me 16m square plus 2 4s are 8, 8 5s are 40mn plus 25n square plus 25m square plus again 2 5s are 10, 10 4s are 40mn plus 16n square. Now you have to combine the like terms. So you can see 16m square plus 25m square. So 16 plus 25 will give me 41m square plus 40mn plus 40mn. So 40 plus 40, 80mn. Then 25n square plus 16n square, it will give me again 41n square. So this is the final answer. Now next question, 2.5p minus 1.5q whole square minus 1.5p minus 2.5q whole square. Now here you can see in between these two expressions there is a minus sign. So what I will do, I will assume this as my a and this as my b. Then I can use my identity a square minus b square, which will give me a plus b into a minus b. So your a is 2.5p minus 1.5q plus b is 1.5p minus 2.5q. So this is your a plus b. Now a minus b. So 2.5p minus 1.5q minus 1.5p minus 2.5q. So this is a minus b. Now you have to solve it. So 2.5p minus 1.5q plus 1.5p minus 2.5q. And here it will be 2.5p minus 1.5q. Now before bracket minus sign, so sign will change. So it will be minus 1.5p plus 2.5q. Now you have to group the like terms. So you can see here 2.5p plus 1.5p. So 2.5 plus 1.5 will give me 4p. And then minus 1.5 and minus 2.5. That will also give me minus 4q. And in the second one, 2.5p minus 1.5p. So 2.5 minus 1.5 is only 2.5 minus 1.5 is 1. So it will be only p. and minus 1.5 plus 2.5, this will give me plus q. Now I can take 4 common, so it will become p minus q and p plus q. And again you can see p minus q, p plus q, it is in the form of a minus b into a plus b, isn't it? And I have already written, if it is in a minus b, a plus b form, you have to write a square minus b square. So from here I can write it as 4 times a square minus b square. Here your a is p and b is q, so it will be p square minus q square. And then you can multiply 4 with p square, it will give you 4p square minus 4q square. So this is the answer for the fifth question. So if you see, if you proceed it slowly, step by step, aram se, you can solve it very easily. Okay, it's not a very tough question. Now moving to the next question. Sixth one, AB plus BC whole square minus 2AB square C. So it is very clear that here I can use the identity A plus B whole square. So A plus B whole square will be A square plus 2AB plus B square. So A square, here it will be AB whole square because my A is AB and B is BC here. Now 2AB, so 2 into AB into BC plus BC whole square minus 2AB square C. So AB whole square will give me A square B square plus 2AB square C plus B square C square minus 2AB square C. Now you can see plus 2AB square C minus 2AB square C, I can cancel. So it will be A square B square plus B square C square. So this is the answer for the sixth question. Now seventh question, m square minus n square m whole square plus 2m cube n square. So here I can use a minus b whole square. So a minus b whole square will give me a square minus 2ab plus b square. So here your a is m square and b is n square m. So let's use the identity. So a square means m square whole square minus 2 into m square into n square m plus n square m whole square plus 2m cube n square. M to the power 4 minus 2m cube n square plus n to the power 4 m square. N square m whole square is n to the power 4 m square plus 2m cube n square. Now you can see minus 2m cube n square and plus 2m cube n square. It will be cancelled because their sum will be 0. So you are left with m to the power 4 plus n to the power 4 m square. So this is the answer. So I'm done with question number 4. Now moving to question number 5. Now question number 5. Show that 3x plus 7 whole square minus 84x equal to 3x minus 7 whole square. So whenever question says show that or verify, we have to show actually LHS is equal to RHS. So I am going to take first LHS, I am going to solve it, then I will take RHS, I will solve it, and then I will show LHS is equal to RHS. Okay, so let's start with our LHS. So if you see in LHS part, it is 3x plus 7 whole square. So here I can use the identity a plus b whole square, right? So first I am writing the identity itself. So it is a plus b whole square. It will give me a square plus 2ab plus b square, right? Now I am going to take the LHS. So LHS is equal to 3x plus 7 whole square minus 84x. Now 3x plus 7 whole square, I am going to use a plus b whole square. So it will be 3x whole square, which is a square, 2 into 3x into 7 plus 7 whole square minus 84x. Now 3x whole square will give me 9x square plus 2 into 3, 6, 6 into 7, 42x plus 49 minus 84x. If there is any like term, we have to combine. So here you can see 42x and minus 84x. So 42 minus 84 will give me minus 42x plus 49. So this is my LHS. Now I'm going to take the RHS. So RHS is 3x minus 7 whole square. So here I am going to use the identity a minus b whole square, which will give me a square minus 2ab plus b square, right? So here I will write 3x whole square minus 2 into 3x into 7 plus 7 whole square. So 3x whole square will give me 9x square minus 2 into 3, 6, 6 into 7, 42x plus 7 square is 49. So if you see LHS and RHS both are equal, so I can write from here LHS is equal to RHS. Okay, so same way we have to do the other question. Now second one is 9p minus 5q whole square plus 180pq equal to 9p plus 5q whole square. So here also, here I can use a minus b whole square. So a minus b whole square is a square minus 2ab plus b square. So I have to take the LHS. LHS is 9p minus 5q whole square plus 180pq. Now this question is same as the first question. Okay, so now use the identity. So 9p whole square, which is a square, minus 2 into 9p into 5q, which is minus 2ab plus 5q whole square plus 180pq. So 9p whole square will give me 81p square minus 2 into 9 into 5. 2 into 5, 10. 10 into 9, 90. So it is 90pq plus 25q square plus 180pq. Now combine the like term. So it is minus 90 plus 180. So it will be 81p square minus 90 plus 180 will give me plus 90pq plus 25q square. Now RHS 9p plus 5q whole square. So here I have to use the identity a plus b whole square, which will give me a square plus 2ab plus b square. So your a is 9p here. So a square means 9p whole square plus 2 into 9p into 5q plus 5q whole square. So 9p whole square will give me 81p square plus 2 into 9 into 5. 2 5s are 10. 10 into 9, 90pq plus 5q square, 25q square. So you can see here again LHS and RHS both are same. So from here I can write LHS is equal to RHS. So this is the second question. Now moving to third one. Third question is 4 by 3m minus 3 by 4n whole square plus 2mn equal to 16 by 9m square plus 9 by 16n square. You have to show that. So again I will take LHS, and you can see in the LHS part I can use the identity a minus b whole square. So I will write here a minus b whole square is equal to a square minus 2ab plus b square. So LHS, now your a square means 4 by 3m whole square minus 2 into a, which is 4 by 3m, into b, which is 3 by 4n plus 3 by 4n whole square plus 2mn. Now if you see here 3 and 3 I can cancel, 4 and 4 I can cancel. Now 4 by 3m whole square. So 4 square is 16, 3 square is 9, m square minus 2mn plus 3 square is 9, 4 square is 16, n square plus 2m. Now minus 2mn and plus 2mn you can cancel. So it will be 16 by 9 m square plus 9 by 16 n square, and this is equal to your RHS. Okay, so third question is also LHS is equal to RHS. Now fourth question. Here it is 4pq plus 3q whole square minus 4pq minus 3q whole square equal to 48pq square. So here if I assume my this as a and this as b, so it will become a square minus b square, isn't it? A square minus b square, which is equal to a plus b into a minus b. So I will take the LHS and I will use first a plus b. So it will be 4pq plus 3q plus 4pq minus 3q. So this is my a plus b. Now a minus b will be 4pq plus 3q. This is a minus 4pq minus 3q. Now 4pq plus 3q plus 4pq minus 3q. I am opening the bracket. And the second one will be 4pq plus 3q. Now before bracket minus sign, so sign will change. Minus 4pq plus 3q. Now something I can cancel. 3q minus 3q and here 4pq minus 4pq. So I am left with 4pq plus 4pq. It will give me 8pq into 3q plus 3q will give me 6q. So 8 6 are 48 pq square. So again I can say this is equal to my RHS. Okay, so this was the fourth question. Now fifth question, a minus b into a plus b minus a into b plus c minus a into c plus a equal to 0. Now here you can see a minus b into a plus b. I can use a square minus b square. Same way b minus c and b plus c. This is also the same identity, right? A minus b into a plus b. This is also a minus b into a plus b. So all are based on the same identity, a minus b into a plus b, okay, which gives me a square minus b square, right? So LHS, first a minus b into a plus b is a square minus b square plus b minus c into b plus c. This is also b square minus c square plus c minus a into c plus a. This will give me c square minus a square. Now you can see a square minus a square 0, minus b square plus b square 0, minus c square plus c square 0. So it is all 0. So RHS is also my 0. So from here I can show that LHS is equal to RHS. So this was all about the question number 5, where I have solved using the standard identities. Okay, now moving to question number 6. Now question number 6, using identities evaluate. Evaluate means you have to find the value, but you have to use identities to find the value. So first one is 71 square. So in this type of question, first you have to find out 71 is near to which tens, whether it is near to 70 or it is near to 80, like that. So clearly I can see 71 is near to 70. So now I'm going to write 71 as 70 plus 1 whole square. And then I can use the identity a plus b whole square, right? A plus b whole square will give me a square plus 2ab plus b square. So let's use the identity. So a square means 70 square plus 2 into 70 into 1 plus 1 whole square. 70 square will give me 4900 plus 2 into 70 is 140 plus 1. And 140 plus 1 will give me 141. And if I add it, I will get 5041. Okay, 5041. So this is the first one. Now second one is 99 square. Now 99 is near to 100. So I can write 99 as 100 minus 1 and then whole square. So here I am going to use the identity a minus b whole square, which will give me a square minus 2ab plus b square. So 100 whole square will be my a square minus 2 into 100 into 1 plus 1 whole square. Now 100 square is 12340 minus 200 plus 1. And minus 200 plus 1 will give me minus 199. And 10,000 minus 199 is 9,801. Next, 102 whole square. So again you see 102 is near to 100. So I can write 102 as 100 plus 2 and then whole square. So I am going to use the identity a plus b whole square, which will give me a square plus 2ab plus b square. So I can write 100 whole square plus 2 into 100 into 2 plus 2 whole square. So 100 square will give me, see, 100 is having 2 zeros, so square will have 4 zeros. So 400 plus 4. And if I add all 10,000 plus 400 plus 4 is 404. 404 plus 10,000 will give me 10,404. Next is 998 square. 998 is near to 1000. So I can write it as 1000 minus 2 whole square. And then I can use the identity a minus b whole square, which is a square minus 2ab plus b square. So it will be 1000 whole square minus 2 into 1000 into 2 plus 2 whole square. Now 1000 is having 3 zeros, so the square will have 6 zeros. So 3, 4, 5, 6 minus 2 into 2, 4, 4 into 1000 is 4000 plus 4. And minus 4000 plus 4 will give me minus 3996. And if I subtract, I will get 9,96,004. So this is the answer for 998 square. Now moving to the fifth question. Now fifth question is 5.2 square. So I can see that 5.2 is near to 5, right? So 5.2 I can write as 5 plus 0.2. So 5.2 square, it can be written as 5 plus 0.2 and then square. Now I can use the identity a plus b whole square, which will give me a square plus 2ab plus b square. So let's expand it using the identity. So it will be 5 square plus 2 into a into b. So 2 into 5 into 0.2 plus 0.2 square. Now 5 square is 25 plus 2 into 5 10. 10 into 0.2. So 10 into 0.2. First ignore the decimal and multiply. So 10 into 2 is 20. Now here after decimal 1 digit. So here also you have to place the decimal between 2 and 0 such that after the decimal point it should have 1 digit. Right? So it will be only 2 plus 0.2 whole square. So 0.2 into 0.2. If you ignore the decimal, it is 4. And in 0.2, 1 decimal place, here also 1. So 1 plus 1, 2. So place the decimal point in such a way that after that it will have 2 digits. So it will be 0.04. So this can be written as 0.04. Now 25 plus 2 is 27 plus 0.04. Now here you are adding one whole number and one decimal number. So you must be aware that how to add this. So first you can write 27 as 27.00. I am trying to convert in like decimal and then 0.04 and then add it. So this will give you 27.04. So 5.2 square is 27.04. Now next 297 into 303. Now if you see this question is very important. 297 is near to 300. Even 303 is also near to 300. So 297 I can write as 300 minus 3. Right? From 300 if I subtract 3 I will get 297. And 303 can be written as 300 plus 3. So can you remember this is which identity? So if you see, if I consider 300 as A and 3 as B. So here it is A minus B, here it is A plus B, isn't it? A minus B, A plus B. And this will give me A square minus B square. So 300 minus 3 multiplied by 300 plus 3 can be written as 300 whole square minus 3 whole square. 300 square is 9 and then 2 0 it will become 4 0 in square minus 3 square is 9. So 300 square minus 3 square, I got 90,000 minus 9, and 90,000 minus 9 if you subtract you will get 89,991. So this is the answer. Now next question, 78 into 82. Now this is also same as sixth one. So 78 is near to 80. Even 82 is also near to 80. So I can write 78 as 80 minus 2, and 82 can be written as 80 plus 2. And you can see again it is in the form of a minus b, a plus b. So a minus b into a plus b. This can be written as a square minus 2a. Sorry, it is a square minus b square, right? So further, 80 minus 2 and 80 plus 2 I have to write in the form of a square minus b square. So it will become 80 whole square minus 2 square. 80 square is 6400 minus 4. So 6400 minus 4 will give you 6396. Now next is 8.9 square. Now 8.9, it is close to 9. So I can write 8.9 as 9 minus 0.1. Isn't it? 9 minus 0.1 is 8.9 square. And then I can use the identity a minus b whole square, which will give me a square minus 2ab plus b square. So I can write it as a square as 9 square minus 2 into 9 into 0.1 plus 0.1 whole square. 9 into 9 is 81 minus 2 into 9 18. 18 into 0.1 is 1.8 plus 0.1 square. So 0.1 into 0.1. Now if you ignore the decimal, 1 into 1 will give me 1. Here 1 decimal place, here also 1. So 1 plus 1, 2. So place the decimal point in such a way that after that it should have 2 digits. So it will be 0.01. Okay. Now 81 minus 1.8. So 81 I can write as 81.0. Subtract 1.8 from that. So you will get here 2, 9. So it will be 79.2. And then 79.2 plus 0.01. So 79.20 I can write. Actually, I'm converting in like decimal. And you remember what is like decimal? Like decimal means two decimals having same decimal place, right? So 0.01 has two decimal place, 79.2 has one decimal place. So I have put 10 at the rightmost end to make it a like decimal. And if I add, I will get 79.21. So 8.9 square is 79.21. Okay, now moving to next question. The ninth question, 10.5 into 9.5. So 10.5 and 9.5 both is near to 10. So it can be written as 10 plus 0.5 into 10 minus 0.5. So now it is in the form of a plus b into a minus b, which will give me a square minus b square. So it can be written as 10 square minus 0.5 whole square. So 10 square is 100 minus 0.5 square. So 0.5 into 0.5. If I ignore the decimal, 5 into 5 is 25. Here after decimal point 1 digit, here also 1. So 1 plus 1, 2 decimal place it should have. So it will be 0.25. Now subtract 100 with 0.25. First convert in like decimal. So 100.00 minus 0.25. So if you subtract it, you are going to get 99.75. So the product of 10.5 into 9.5 is 99.75. Now question number 7. Using a square minus b square equal to a plus b into a minus b, find first one, 51 square minus 49 square. Now it is in the form of a square minus b square. So I have to write a plus b because my A is 51 and B is 49, and A minus B, which is 51 minus 49. Now 51 plus 49 will give me 100, and 51 minus 49 is 2, so 100 into 2 is 200. Second one, 1.02 whole square minus 0.98 whole square. Here also it is in the form of A square minus B square. Your A is 1.02 and B is 0.998. So A plus B is 1.02 plus 0.98 and 1.02 minus 0.98. Now if you add 1.02 plus 0.98, you are going to get 2.00, which is equal to 2 into 1.02 minus 0.98 will give me 0.04, and 2 into 0.04 is 0.08. Third one, 153 square minus 147 square. Here also it is in the form of A square minus B square. So it will be 153 plus 147 and then 153 minus 147. So if you add 153 and 147, you are going to get 300, and 153 minus 147 is 6, and 300 into 6 is 1800. Next, 12.1 square minus 7.9 square. So again it is in the form of A square minus B square. So A plus B, 12.1 plus 7.9, and A minus B. If you do A plus B, 12.1 plus 7.9, it is 20.0, which is equal to 20. And 12.1 minus 7.9 is 4.2. And if you multiply, you will get 84. So if you ignore the decimal and multiply, you will get 840. But in 4.2, after decimal, one digit. So we have to place the decimal point here. So 84.0 is 84. Now moving to the next question. Question number 8. Using x plus a into x plus b equal to x square plus a plus b whole x plus ab, find the value of 103 into 104. So you have to use the given identity and then only you have to find the product. So your first step is to write 103 and 104 in the form of x plus a and x plus b. So we can see both 103 and 104 is near to 100, right? So 103 I can write as 100 plus 3 into 104 I can write as 100 plus 4. So now you can see it is in the form of x plus a into x plus b, where your x is 100, a is 3 and your b is 4. Now you have to use the identity. So x square means 100 square plus a plus b means 3 plus 4 times x. X is 100 plus 3 into 4. Now 100 square is 10,000 plus 3 plus 4, 7. 7 into 100, 700 plus 12. And if you add everything, you will get 10,712. Second one, 5.1 into 5.2. So now 5.1 you can write as 5 plus 0.1 into 5 plus 0.2. Now if you compare with the given identity, your x is 5, a is 0.1 and b is 0.2. So x square is 5 square plus 0.1 plus 0.2. A plus b into x. X is 5 plus 0.1 into 0.2. So 5 square is 25. 0.1 plus 0.2 is 0.3. And 0.3 into 5 will give you 1.5 plus 0.1 into 0.2. 0.02. Because see here after decimal place 1 digit, here also 1. So 1 plus 1, 2. So in the product after decimal it should have 2 digits. Now 25 plus 1.5 is 26.5 plus 0.02. So convert into like decimal and then add it. You will get 26.52. Third one, 103 into 98. Now 103 is also near to 100, 98 is also near to 100. So I can write it as 100 plus 3 is 103 and 100 minus 2. So your x is 100, a is 3 and your b is minus 2 here. Okay, so you have to be very careful. Here b is minus 2. So now use the identity. X square is 100 square plus a plus b means 3 plus minus 2 times x, which is 100, plus 3 into minus 2. Now 100 square will give me 10,000. 3 plus minus 2 is 1. 1 into 100 is 100. And 3 into minus 2 will give me minus 6. Now 10,000. 100 minus 6 is 94. And if you add it, you will get 10,094. Last one, 9.7 into 9.8. Now 9.7 and 9.8 both is near to 10. Now you can do this in two ways. You can write 9 plus 0.7 into 9 plus 0.8 like that also. Or you write 10 minus 0.3 into 10 minus 0.2. So it's up to you. Now here your x is 10. Your a is minus 0.3. Okay. And b is minus 0.2. Now those who are having confusion with negative sign and all, better you use 9 plus 0.7 and 9 plus 0.8. Like that you can solve. Now I am using the identity. So x square plus a plus b means minus 0.3 plus minus 0.2 times x, which is 10, plus minus 0.3 into minus 0.2. So 10 square is 100 plus minus 0.3 plus minus 0.2 is minus 0.5, and into 10 will give me minus 5 plus. Now you are multiplying two negative numbers, right? So the product will be positive. So 3 into 2 will give me 6. But here one decimal place, here also 1. So 1 plus 1, 2. So 0.06. And then 100 minus 5 will give me 95 plus 0.06. It will give me 95.06. So now I'm done with the complete questions of exercise 9.5 from the old Ncert textbook. Now in my next video, I am going to pick few important questions from R.S. Agrawal and I will be solving that. And you will see there will be some question which is very important not only for your academics, but even those type of question is getting asked in many competitive exam as well. Okay, so stay tuned for more videos. Please like, share and subscribe to my channel. Thank you.